Hi guys, today I will show you how to use my new script for map analysis, and this is script that created by me to analyze maps to extract the maps from the raw HDR data. So firstly you will need a Python and Anaconda. uh, I suggest you Anaconda, and also I suggest you JupyterLab or Jupyter Notebook. It depends from what you prefer. So here's the script. The script has two big parts. So installation, imports and functions, and run all the code below to get data. So these parts consist of three parts. Firstly, installation of different packages. Or you could use my environment that I will put in the folder too. But it's a bit harder, and if you will get some problems with that, ask me. I will help you to activate this environment. So yeah, you need to run this cell only one time when you set up all environment and all your stuff per one PC. So per one machine and environment. If you will change environment, you need to manually install it through the command prompt, for example, or to install from the pip out here. So yeah, but you need to do this only one time. I mean, you don't need to reload this cell after, for example, restarting the script. And here, this is a commentarian process. I commented this line, and you could just delete it. For example, delete all these symbols to proceed the installation. Yep, sorry. Yep, so let's imagine that you install this as I did. Then we have the next block in the first big block. It's called imports. So we need to import this cell every time when you start your notebook. So when you open this notebook, you need firstly after first installation, you need firstly run this cell. You could do it by this button, for example. In Jupyter Notebook, there is the same stuff, and yeah, or you could just press Shift plus Enter. So let's do this, yeah, and that's mean these numbers here in this square brackets means that the procedure is finished and all is okay. If something will be bad, we will have like an error. Like for example, I will try to show you showing the error. Yeah, for example, now as you see, this is an error, syntax error, because the Python thinks that I correspond to the variable, but there is no variable such. So yeah. So the next step is to import, as I said, and you need to do it every time when you restart the script and Anaconda, if you use Anaconda, in your environment. Okay. So the next step is the functions. There is a lot of functions, big functions, and you don't need to go through it. There is a bit of code and other stuff, but you don't need to look at it. This is for me and for my adjustments and for my debugging process. So the most important part here, and of course you need to just run these cells like this. I do it with Shift plus Enter, and there is like a different function. I tried to left info for different functions for your understanding if you want to understand this, because this is not properly for usage of these scripts. Yeah, and we have like we run all the functions and put them in the memory of the Python. So one of the thick moment here is this function. Oh, sorry, I need to delete another import. Yep. So this is auto accept. For now, it's true, but in your case, I will ask you to use parameter like false because you need manually. I just used auto for true, for auto acceptance and for debugging process. For now, I will show you. I will put here false, and I will show you what you need to do, how it's working. But then, for the full procedure, I will show you with the auto parameter, auto accept true. So, and if we change something in a cell, we need to rerun this cell, obviously. Then, the second big block. It contains only few cells, and this is when you need to, for example, if you want to look through a lot of data, you need just rerun these cells and change somewhere here something. So obviously, I tried to do this script very automatically, working as it's possible. So for our purpose, you need to change only this folder. For example, we have um, for example, this is my folder that I have a data here, and for example, I want to put here this folder. This is folder with all the raw files that we have, and very important to our files need to be named properly. So I could adjust it for other projects, for example, this script, but still, this is what I asked you. And I don't want to reduce the script because of, for example, wrong naming in our experiments. So please be very precise in case of naming. So what I'm doing next, I'm just copy this path from the Explorer of Windows. So yeah, I just copy it and put it inside the quotes because this is very important. Don't touch this button, this symbol, because it's important for understanding that this is just a string and other stuff. This is a t moments in Python. You don't need to understand. So, and this is our dictionary. Dictionary in this case, this is one of the this is our database structure in case of this analysis. So here you could see and you could check here. Does the script works well? And does it put, for example, here could be like other participants because we could put here we could put folder with all different participants raw files, and it will be work. So so here will be like different participant names, and here's the condition, and here the paths for these files. And you need to check does it work correctly. So this is B1 baseline 1, and yeah, it corresponds directly to our condition and that we recorded. So the next step, this is a data processing function. You don't need to understand what's happening inside. You could look into my codes, but it's hard for understanding. Yeah, but I try to do my best in this case and do the script as simple as I could. So this is just function about filtration, about epoching, about other stuff you don't need to understand. You just need to run it, and it will take some time, but not so much. As you see, it's already finished. And here output of our cell is our new processed data dictionary. So this dictionary contained firstly pass. So I added to our previous participant dict. I added some new features, some new case and values to them. So pass, as we saw here, for example, the same structure. Then also for every file I add frequency because it's important for analysis and for filtration process. Also channel list, channels list, sorry, like what muscles we recorded, and then an objects of different epochs correspond to different channels, to different muscles in our case. So for example, this is for biceps, this is all epochs correspond to TMS pulse and two maps, obviously, in a window from -1 second before TMS pulse and plus 500 milliseconds after. That corresponds. So here we have 15 events because we have 15 pulses and 15 epochs there. Yeah, for biceps, for triceps, for FDI, APB, and ADM, and the same for different conditions. For example, for V1, for kinesthetic, etc., etc. So yeah, you don't need to look through this data. This is not so important. So the next step is the most important for us. It's the most important for people that are hands for this case of analysis. This is a function that plots all our maps, all our epochs here. You need just to run it, and then you have like this window. I try to adjust it for every screen, but maybe something will be wrong, and you could write me, and I will try to change every step. So here is the first epoch, first pulse that we have, and we have here a map. Uh, yeah, sorry, this Sabaka will fix it, but still, you will have these dots here and here on the maximum and on the minimum here, and you could see here this is just a visualization process, not a process of counting values, etc. So this is our peak-to-peak amplitude, and here you could see that the blue line is our signal filtered, etc., and um, black line is our TMS pulse when it came. And here, like only timestamps for this red and green line. This is only timestamps for the maximum and minimum. As you could see, for example, this, I don't know, is this red dot need to be here. So I just did something with my code because I tried to debug it with other stuff. So we have a maps. You could see that the map for this case is good. Our peak-to-peak amplitude is good. For example, you do the same for the other muscle. So this biceps, triceps, FDI, APB, and ADM. You see that's all is good, and you go down. Here the block where you need to put a number 1 or 0. 0 mean you refuse the data. You refused, for example, if you wanted to refuse the first trial, because it's, for example, let's imagine that it is bad. You put here a 0 and press enter. Then the code will plot for you the second epoch for every muscles and for every condition. We could do it with you, but it will take a lot of time. But for example, we decided that this maps is good enough for us, and we will put in this case here 1. So one more time, 0 to refuse all the trial, and 1 is for accept the trial. For example, I will accept several trials, etc., etc. Yeah, and there then in our in our final table, we will see just empty rows with nones, filled with nones. Yeah. So, for example, you did all this process because this is iteration through all conditions, through all the epochs, and if we will and obviously for all the muscles, but through all the muscles, but it also could iterate through the participants if we will put every participant in the same folder, like raw files, as I said. So, and for example here, we have results for peak-to-peak results. This is that this function returns. So firstly this function call another function that plot this stuff, and pick-to-pick results. This is our final dictionary. You could look at it like on the data frame or on the table, because the type of data is different, but still for our purposes it's okay. Yeah, so what we see here, we see also the participant name, the condition, and then, sorry for like sliding here for empty space, but it's okay, this is just a Python visualization. You will look at the Excel file, what's happening there. So our pick-to-pick results, as you could see, this value correspond to the biceps, this is to triceps, this is for ADA, APB, and ADM. And this is values from my previous cell running. I mean, not in this case, because obviously there is an error, because I stopped all the stuff. So this is our values. I compare these values with the Pavel script, and they are quite my script is quite precise, because our differences only in 2 signs after the comma, so it's a good precision in our case, because this is a data analysis and filtering process. It's hard and you don't need to understand. And then you run the final cell to save this. It's another function. You need to save this dictionary to the Excel file. So and this Excel file will be stored in the same folder that you put at the start here. So here you put a folder with all your data, raw data, and this file will be stored at the same folder. And here the final path of this file. So I will show you. Yeah, this is the same folder. You could do that like this, and there is this file. Wait a sec, I will show you. So this is how the our data look in case of sorry. Um, this is how our data looks in case of Excel. So I was asked to change the dots to the commas, and so this is the reason why there like a problem with dots of the picks and those, but still. So this is our data. You could use it, obviously. Here are the values, not from 1 but from 0, but it's okay, it's 15 of them. And all values, all the values, I compared them to the Pavel script, and all is working good. Maybe it wouldn't work so good in case of dirty raw files, for example. But this is another problem, and nobody could count on this, because the dirty raw files, corrupted data, isn't something good. We need to avoid it in any case. So you got it. And for now, you could use like our manual analysis, that tutorial that I recorded for you before, and you could just proceed as the same Excel file. Whatever you want, whatever you like, but still collect this data. Don't mess with the data, as I said. So, yep, I think that's all. If you have a question, just write to me or ask in the lab. If you have some problem with environments, this is an appendix, add, addition. Yeah, and after you run the functions one time, you could close this, because this is not something really important. So if you have with problem with this one, or with the imports, for example, some error occurs, or something bad happened there, write to me. I will help you with the environments. This is tough stuff. Yeah, so I think that's all. Thank you for your attention. Please be um, polite in case this code. I try to do my best. And try to be precise. And if you have comments, different comments, for example, you think that the graphs on your machine looking not like this, for example, something bad's happening. I just try to do to make these graphs visible good. I mean, to put the like big graphs. I couldn't make it interactive because of the technical problem of different machines and different modules. But still, this is a good code. I hope, I think. So, write to me. That's all. Bye.